Mr. Diaz! Man, you have been so patient. And I can't thank you enough for being so patient. But brother, here's your new but used, new box. Oh shit, I'm teasing you. Here's your box. Now Eddie here, he gets an award. As you've seen in the intro pictures, there was about, just underneath the cabinet, down between the heat sink and the bottom of the cabinet, about a half a pound of hair. Dog hair, cat hair, something. I don't know if he kept this thing in a closet. I don't want to know. I don't want to know. I know when I first took it apart, I took the air hose and outside, right? And there was this like chrysalis of hair and dirt and shit that fell out of this thing. Then I used 2.5 cans of electronic chemical wash to get it this clean. But Mr. Diaz here, he gets the award for the dirtiest amplifier ever sent in for massive overhaul and complete teardown and repair. This started out in life as a 2x6. It's an old Carl team built box. I guess there's some issue with that now. If you say Carl built, they get upset because it's supposedly the same team or what. When it was underneath Carl's regime, when Carl owned the business, this is when this amp was built. And it fared the weather pretty good, taking into account how dirty it was underneath. I went through and I pulled all the resistors out and replaced them with 5 waters because that's what Eddie wanted. He wanted the full BBI, full meal deal. And there was a little 2-pill driver section that was over here that we took out. Now the other thing we had to do is when they built this box, they only had a little piece of heat sink in here just big enough for a 2-pill section. It was mounted, and then the rest of this was taped off with copper tape and then boxing tape underneath. Well, we took all that down, took the old heat sink out, took the whole board out, mounted in a new piece of heat sink that goes from the leading edge of the cabinet all the way back here, even with this one. And yeah, I made an artistic choice. I wanted to do a bunch of 2-pills. And haven't done one of these for a while, actually. Normally what most builders would do is they'd pull all the wires out of all of these, and they'd rewrap them for the 2.5 turns, and then they'd put a combiner here, and then they'd add another 2 pills here, and they'd add a combiner here. And then they'd add the second 2-pill section over here, which I could have done, which would have, I guess, worked. It would have been the cheapest way to go about doing it. But you all know me, that's not the way I play. Because if it can be done a little bit more expensively and with a little bit more pizzazz and a little bit more flair and a little bit more style, that's the direction old BBIs are going. I wanted a more heat sink underneath the box, really. By the time the air gets to the end of the heat sink here, on this side, it would have been in completely overload. The air exhausting from the side of the cabinet would have not been even whatsoever. This would have had a lower pressure. These transistors would have stayed cooler, and not go that route. Pulled heatsink off, completely redid. Bridged over all the bus bars, added a capacitor bank to it, of course. Pulled the 3-port combiners out. Let's see if I got one laying around here. That's the input splitter, actually. Pulled the input splitter out, and we replaced it with a brand new 6-port. So this is an individually split, single-stage combined box. Instead of there being 2 layers of combiners, like I said, we could have used the standard 3 ports that stayed in here and done a 4-port bank and then a 4-port bank, a 4 transistor bank of 2 outputs and combine them and have 1 output, and then 1 output off this 4. I could have done that. But man, that ain't no fun, right? This side's using the BBI new transistors. This is using the old school Xforce, everybody else made style transformers. And of course, as always, this is a match set of 6. They're within 1 beta gain of each other. And on this side, I'm using aircraft grade Teflon, which is dual shielded. And what I mean by dual shield is there's 2 layers of Teflon before the wire. That way you get the highest possible resistance to heat and chafe breakdown on the wire possible anywhere. How do we know this? Because the wire costs almost 3 times what this costs. or what this wire is here. It's a single shield. 3 times. So if I was paying $1 a foot for this, let's say, which I'm not, you only pay like 23 cents. This stuff I'm paying $3 a foot for. It's just, well, that much better. Just that. Eddie, you're going to love the performance of this thing, brother. Your amp case is all cleaned out. I went ahead and went over the outside of the case and got it all cleaned up so it looks somewhat new now. Also did the lid and washed the fans. All that aside, let's get this out of here. Okay, let's see. Let's make sure we got all our switches in the right position. Nope, they're where I ended up when I got done tuning it. I didn't have to do a lot to this thing, man. As far as the tuning, I got everything right on the money. Dropped it in there, bam! Able to key it and not have any problems. So we're going to use the Benchmade 1x2, which is a phenomenal little box. And I love these cases, man. Big fan, lots of heat sink, good exhaustion, not the little tiny 2-pill cabinets I use. Good build here. Okay, grab our test microphone. We're going to start off with a 1,000-watt slug. This is our PEP meter, of course, 1,000-watt slug in average, and a 5-watt slug in reverse, coming back from the Bird 10,000-watt dummy load. We're going to use the Striker 955 and the Bird watt meter with a 5-watt slug in reverse between the 955, the 1x2, and of course the 12-pill. Okay. We're on 1X, so full deflection on 100 is 1,000 watts. Ooh. Oh, almost broke it. Almost broke the T's. Had it on still. Let's show you drive from the 955. Hello, audio. 80 whole watts. That's not going to change. That's going to be our baseline. Let's go ahead and establish this. Hello, audio. Hello, audio. Nice, beautiful 600 watts out of the 1x2. It's a screamer, baby. All right. So with 80 watts of drive, and I already know what's going to happen. Check this out. Hello. 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 Yes, I'm physically laying the needle on the stop peg, which is really hard on the meter movement, and some guy out there is freaking out right now. But nope, that's just the way we roll over here. And I've come to learn that people really kind of do get a kick out of that. So we went up to 2X. What does 2X mean, you mean? Well, right there between the 40 and the 60, you see that? You see that little hash mark there? That's 1,000 watts, right? Hello, audio. 16 and some change with 80 watts of input drive. Scary, I know, right? When you get everything perfectly in tune, you don't have to struggle with it too awful bad. The thing just takes off and goes. Oh yeah, forgot to add, I upgraded all the power wires, which is pretty obvious. This actually allows each transistor bank to put out about 20 more watts. Bird power works out to be about 10 more watts worth of power by doing it this way. There's a lot of people that debate out there in the little chat groups everywhere. They're, oh, it doesn't make a dick of difference. Well, I come out doing this here a couple years ago, and I think it's kind of odd how everybody else in the industry is now feeding their transistors this way. Now, I'm not saying I'm the one that created this, because I'm not. Palomar, and if you go back and you look at the old Motorola books, and that's where I got it from, Motorola suggested that you directly feed each one of these devices. That's the way it's supposed to be done. It's not the cheapest way to do it. They found that if you go directly through the transformer and then back to the distribution bar with a little tiny and not as big a wire, it's way cheaper in the overall. If you're building like 150 amps, this would save you about, right, not having this in here and going off of here to here, would save you about $380. Spread out over a mass construction. Well, since I deal with everything on an individual basis here and I'm a custom shop, I frankly don't give a shit about my profit margin because, well, I have another job that pays all my bills and I do this for fun and I get a kick out of it. And I truly do get a twisted kick out of seeing some of the stuff people say. Facebook, YouTube, Instagram, Snapchat, and Twitter. It makes me go, what the hell? I wish I had that much free time. Anyhow, that's the reason I do this, is because it makes the transistor run cooler, because it's not having to work so hard because it's not straining for amperage. 2, it's a better amperage delivery system to the transistor. And 3, it looks friggin' pretty. Now everybody's doing it, all but one guy. Which is great, because we get to preserve the life of the transistors. And the little Toshibas thank us greatly. There's less amperage loss. And that's why you can put 80 peak watts into a 12 pill and get hello audio. 16 to 1700 out of it. We're going to drive it a little bit harder now. I'm going to flick this down to 5x, okay? 10 is 1,000, 20 is 2, 30 is 3, 40 is 4, and 50 is 5. So we're going to add a couple zeros. I bet you we end up somewhere right in this area, which is just about the theoretical max that you're going to get out of this box without volting up. Now, if anybody's ever watched any one of my little videos, you know for a fact I work on 14.5. And I got to revisit this over and over and over again. Well, why do you use 14.5 BBI instead of using 15 or 16 or 17, which would get us all kinds of really cute watts? It's a standard. Unless somebody's going to modify the electrical system in their vehicle, or they're going to go and use this on a, home power supply. Well, unless I can directly replicate their voltage and their amperage supply on their end, which I can't in every single video, then I have to go with the standard. So I picked 14 flat or 14.5 because I figured that was a voltage that everybody could get to. Check it out. Hello. Sweet, right? We're going to run our dead key up a little bit. It's a 1500 watt dead key without the tin on. Nothing's getting hot. Nothing's going to blow up. Go ahead and we'll back this down a little bit. Back that down to about there. Hello audio. Hello audio. Hello audio. It's a beautiful thing. Eddie, it's been a pleasure, buddy. I'm sorry it took so long. I had some other things come along. I had some other problems to overcome, like this little guy here. This is a blocking capacitor. It's supposed to look all pretty and shiny like that on this side. Well, that's what happened when you go to a little bit bigger tube. And this thing is a little bit too close to the case. It needed to be about that far, and it ended up being about that far, and it arced out. I had a whole bunch of problems over here I had to take care of on my personal stuff, and I appreciate your patience, Eddie. Little expensive problems like this. Here's another one. Oh, I'll grab this. Get down here close. This is another blocking cap. You see all those little pin pricks? It's not a flash over. It's not that something arced to it. It's that there's two pieces of wafered metal with a mica in between to go down the middle of this, two little pieces. It shorted over and blew through this metal coming out. I had a bunch of little parts like this I had to go hunt down and find and replace and fix. That's what got in the way, Eddie, and I apologize to you, brother. But homie, your box is done, man. That's all there is to it. Hello audio. Hello audio. And the neat bit is hello audio. Pulling about 160 amps. Now, you can hit this a little bit harder. I wouldn't suggest it. You can hit this with like a 4-pill and loaf the 4-pill into this. But ultimately, really, for the life of the box, you want to run a 1x2. Just saying. I don't get to be here without all of you. It's the truth. Eddie's another dude that's 10/8 and straight and cruising now. He's going to friggin' love life. He's going to hook this thing up, and then he's going to get to experience all the other things that are going to change because his wattage output has literally doubled. He's probably going to have some coax failures, and he's going to have some mount failures, and he's going to have some antenna problems. And once he overcomes all that, this thing is just going to cruise for him. It's part of the CB learning game, part of the radio learning game overall. Break stuff, learn how to make it better. I don't get to be here without all you. Another dude, 10-8 and straight. My name is BBI, and without a shadow of a doubt, I am the biggest mud duck coming out of Idaho right now here today. I don't know how long that's going to last. I'm not too overly concerned since I'm getting ready to build something like ridiculously big. Please, dear God, help me don't electrocute myself building this next project. But that being said, I appreciate your all's support. I'm having a blast with radio. I'm having a blast getting to teach you guys all about this stuff, and I hope you're all enjoying it. I don't get to be here without your guys' projects, and I don't get to be here without you guys having a true belief in what I'm doing and trusting me with your stuff. That's the reason I shoot these videos. That's the reason I hold myself accountable in all public venues. I appreciate you guys from the bottom of my heart. I'll see you. Bye.